We are on to what's called, so again, we're going to do more lines and angles inside of circles. And we are going to, in this one, talk about inscribed angles. An inscribed angle, we'll draw a picture of it and then we'll define it. We've got a circle. And an inscribed angle is on an angle that's on the inside that touches one of the sides. It does not have to go through the center. The center doesn't matter here. So it just touches one of the sides. So an inscribed angle. Inside the circle, an angle inside the circle that is on the circumference. It's like touches the side. And then in doing this, I'm going to compare these inscribed angles with the central angles from the last one. And these are like the two that kind of go together. So this is from 12.2, real quick, a quick review here. This is the central angle. And in this one, we've got the central angle looks like this. It's in the center. And in this, we said the angle is equal to the arc. That's what we just did. Now, in this one, the inscribed angle. The angles and the arcs just have a different relationship. In this one, the angle is 1/2 of the arc. Now, just to make sure you understand, like, why is it 1/2 the arc? I'll draw it out, and you guys don't need to draw this. But let's look, I'll draw it really big over here. And we have a central angle. Now, if I keep this same arc, right? So I'm going to keep this arc the same length. And then I'm just going to move the angle around. So I'm kind of like highlighting this arc that we're going to have. So the angle's always going to be like inside of that arc. The further back I move it, if you guys can start to see, the more and more back it goes, the smaller, I missed with that one, but the smaller and smaller that angle gets. You can almost think of it like a bow and arrow, right? Like if you're pulling the bow backwards, right? The further back you pull it, the more acute that angle gets, the smaller that angle measure gets, right? And then the same thing would be true once we move it forward, right? If we start to move it forward this way, do you see how the angle gets bigger and bigger and bigger, right? Until it gets all the way up here and it goes straight. See, look, this is our arrow now. Right? Does that make sense? It's like a little bow and arrow, right? The further back you pull it, the tighter the angle gets, right? You let go and that angle starts to get flat, right? And it pushes the arrow going forward. So the relationship here is because this is in the middle and this is on the other side, right? The relationship there is 2-to-1 because it's in the middle, right? It's like twice as far. So all you guys got to know now is that the angle is equal. So if it's in the middle, a central angle, the angle is equal to the arc. If it's an inscribed angle, the angle's half the arc. Now they're going to do a whole bunch of crazy problems that are going to mess with you thinking about all of those types of things. So here's some examples from what they could have. And then again, it could get more and more and more complex. they could just give you something like this. They could say, this arc here is, let's go with, I don't know, 30 degrees. So then what would this angle be? We'll just go X and Y. What would this angle be? And what would this angle be? So in this example, what would X have to equal? 30 degrees. What type of angle is that X? Central or inscribed? And so then what would Y have to be? And what type of angle is Y? Inscribed. That's right. So they could do stuff like that. And then they're going to do all sorts of other crazy like ways for you to think about and break this down. Some things that you'll have to know is like the distance all the way around a circle. How many degrees would it be all the way around the whole entire thing? 360. Right, 360. So keep that in mind because you might have to like subtract away from 360. You're also going to need to use triangle sum theorem. You'll also need to know how many degrees are in a quadrilateral, right? There's 360 degrees like in a rectangle. Yeah. All right. And now here's a different type of thing where it's the same concept. This is a different type of inscribed angle, but it's called, what's it called? Make sure I'm using the right. This is tangent angles. And tangent angles, these are just like inscribed angles. Let me draw up the tangent angle. We're going to have a tangent line. And then with that tangent line, we could put another line anywhere. Like, let's just put it like that. I want to show you guys the angle that's inside of this angle here, or excuse me, that arc here. It's the same relationship. The angle is equal 1/2 of the arc. It's just that the arc is this one. So if you look up here, we're saying this arc, there's a relationship between this arc and this angle. You can almost think of it, it's like the little angle that's inside the alligator's mouth. Look, rawr. Right, see the arc that's inside of the alligator's mouth? Same thing, the arc inside the alligator's mouth. Well, just the alligators just face differently now. Look, rawr. I'm glad I'm recording with those sound effects. Rawr. The angle that the little alligator, or excuse me, the arc that the little alligator is eating. So because this is on the circle, we know that the angle is equal to half the arc. So again, the only real thing in this lesson is reviewing that if it's an central angle, the angle is equal to the arc. If it's an inscribed angle, the angle is half the arc. They are going to have you apply that a whole bunch of different ways in the work. That's it for the lesson. I'll come by and help you guys when it comes to the work because some of it could be tricky. This is a great one to work together with. Really help each other out. All right, so I like how you guys helped each other out in that last one. You're going to need to help each other out a lot in this one.